This is how to use the Bruker multi system. It has this manual front door, okay? That's the cool thing about this system. Clearly, it's open, so if we ever close it, there'll be the door in there. But right now, it's cool, it's all open. Okay, I like to keep the plate in the instrument. So to kick the plate out, you're gonna go to the control software here. You can see that it already has this MTP 384 plate in there, and it says it's out. So if the plate is out, then that means it's out. So somebody has kicked the plate out. And then so if it says it's out, that means this area is not under vacuum. So you can go ahead and you just want to lift up from the bottom of this door, and the plate's already there. If the plate was not already out, you would just hit this eject button here. That's to put the plate in and out. It'll tell you that it's docking the carrier, and that'll kick the plate out and it'll put it in that same area. And once it says out, like it did there, then you can go ahead. And then I like to close the door when I'm not doing it. And again, to close the door, you're gonna pull it all the way up so these brass things slide into that, and then you're gonna make sure that the line on top is in line, and then push it closed. Manual door. Okay, I'll have you practice it. And then here's the plate. This plate detaches if you push this lever from the back, if you want to remove it to clean it. Otherwise, you can go ahead and just spot a clean area on the plate, just like before. Plate. This is the most important part. The laser fires from this way, so the plate needs to go face forward like this, the bottom notch like that, okay? The only way you can really mess up is if you put in the plate backwards. There's a slot, right? So like this, and you pull on this thing again, all the way up, make sure those notches are out, and then it goes forward. And then again, there's a groove right here. So like this, forward into the groove, and then you just push it all the way in, and then you can close it again, make sure that it goes into the groove there, and then line up the top, and then it's closed. Okay? That's it. So I'll go ahead and pull it out so you can go ahead and do it. We practice. This thing's supposed to like pull this out when you open and close it. So I just lift it up again if it doesn't quite grab it. So yeah, go ahead. Let me close this up for you so you can practice opening. Alright, so from the bottom. Yep, all straight up from the bottom, all the way up. Yep, and then make sure that those tabs come out all the way, right? You did, so you're good. And then you're gonna go ahead and do that. And then yep, you're sliding it into the groove. All the way in, perfect. And when you lift that up, make sure you get it all the way up before you push it down, because you want to get those slides in. See how you want to go all the way up? There, see? Those brass slides need to go all the way in. And then you want to make sure that this top line is lined up. All right? So the O-ring seal's right. Right? There you go. So this is the Flex Control software. Once you have it closed and sealed correctly, you can go ahead and load the plate by clicking this little eject looking start docking sample carrier button. It's going to identify what type of plate it is, and it's going to pull it into the instrument. You'll hear all the little noises it likes to make when it breaks vacuum and pulls it into the lock. Then eventually you'll see, just like on the other instruments, like your plate moving around in this window of the camera. You can see the plate is in here. Again, navigation on this plate, you just left click. So left click on the mouse to move around and walk around, okay? Again, same as most instruments, you just click on the position to go to that position. I know the little laser aim button is in the bottom right corner. I can't move that anymore. That's as far as it goes mechanically, so it's an unfortunate thing. So you're moving like this. That's how you're moving, okay? And then clearly the laser is gonna shoot where the crosshairs are. To put on a method you want, I have a method set up for reflector positive peptides for UCI. People usually mess around with it, so I always open it up fresh by going to select method from list. Don't save the method. Reopening this peptides. There's linear positive methods. You can ask me which method to use. This instrument's more sensitive in reflector mode. So I think you can see polymers up to 10K in reflector mode on this instrument. It looks like somebody saved it. So we want to move the mass range. For you, maybe we'll go like 1,000 to 10,000. Once you have the method set right, where's your position? Your D?
H.
H. H1, H2. All right. So on this instrument, the things to notice, we are in small laser spot size parameter mode. we're at 5% laser power. I think it's easier you get more bang for your buck if you go to like a minimum size or medium size. If you want to lower, so if you're going to lower the laser power, your data's too intense, you go up to medium size focus. If you're having bad sensitivity, you can go down to minimum size focus. I don't mess with the large or any of that stuff. Or you can leave it in small, which is in the middle. That changes the diameter of your laser spot, and that actually distributes the power better than going and messing with this too much. So I usually keep this between 5 and 10%. And then when you're ready to shoot the laser, everything's set. You hit start to fire the laser, and then you can walk it around manually when it shoots. And it takes some time to ramp the laser as well. You can see that in there. There we go. We'll wait for it to fire. There you go. You can see it shooting the laser. You can see data showing up. And so that's what you want to do. And then you can add in accumulated spectra or change the laser power a little bit or the focus. Once you have a bunch of accumulated suns together, you can save the data by going to Save As and then finding your group. If you're at UCI, you can find your group in the UCI data folder or make yourself a group, and then you can save your data into your folder, okay? Just make sure you're remembering to save either the sum or single spectra. I like to save the sum spectra. When you're done saving your data, clear the accumulated spectrum, clear the sum, so when you go to the next sample, you can add in a new sum, okay? So clear sum, save as, put it in your group folder, and then I'll show you when you're done, we can switch to linear mode method that works. All right, so you finished with the reflector positive method. The linear method, which has a higher mass range sensitivity, that I like is this one here, LP. There's a couple LP ones in here. This one's pretty good. There's a couple custom ones, but we'll use this one. And this is a pretty big range. It's going 10,000 all the way up to 130,000 minimum. So you can change that if you want. You said 5,000, so let's bring this down to maybe 4,000 or so. And you don't need it as high, so we can bring this down smaller. We got even lower, maybe. There you go. And so now that it's all changed, you can just go back to your first spot, and you should be able to shoot and see. Just to realize in this one, you're going to usually have a deflection gate in the spectrometers tab, so you don't want to go too close to that gate. So if that's at 1,000, you could probably be at like 1,500. That's going to actually block, electronic gate block the masses below that range. And so that's perfectly fine for here. Yeah, I mean, it's going to be pretty obvious if you have stuff that looks well resolved. Not seeing it yet. But yeah, anyways, that's how you do a linear mode method. You can mess around with it in there. The other thing I like to show people where they can mess with is that if the random walk is getting to be annoying, like right now it's on complete sample random walk, so when you click on it, it moves around on its own, you see? You can get rid of that by just taking it off. And then you also can slow your laser down. We're at 5,000 hertz right now. You know, sometimes people want to go to 50 hertz, and then it just kind of moves around a little slower. You know? You move it as slow as you want, and then you can change the number of accumulated shots. So you don't need to do 10,000. You also could just stop it when it's firing. But you know, I'll do 500. I'll do 1,000. You can just mess around with those things as you add in your sum. All right, and then again, just saving it when you're done. So once you're done acquiring data and saving it, I like to leave the plate in. I think the system holds vacuum better with the plate in the instrument, then we always know where it is. So if you're going to spot it again, go ahead and you can kick the plate back out by hitting the eject button like at the beginning of the video. Otherwise, if you're done, you can just leave the plate in. You do want to sign into the MALDI logbook here. It's in your Chrome browser. It's up here in the link. You just click this and then log in your time, and the instrument that you're on is this Bruker Ultraflex Extreme. I sometimes just put like how many hours, minimum 1 hour in the comments. Sometimes the start time, date stuff is confusing. Make sure you fill out the logbook. And that's about it. To process your data, you'd go to Flex Analysis tab here. You can then click on the Open Data, browse to your data folder. Right, so in here, and then when you click on your folder itself that you've created, it will show you all the runs here, and then you can select which ones you want to hit open. Okay. Once you have all the data open, if you want to peek pick or do, hey, it looks like you did pretty good there. That's actually like probably the polymer right there, that blob, right? If you have defined peaks and you wanted to peek pick them, you can click on this button here which says Find Mass List, and that will find the mass list and put a table over there. Put a, well, eventually it'll focus, let's see. Put a table over there and label your masses for you. And then you can export data as a text file by going to File, Export, Mass Spectrum Data, or these files actually drag and drop directly into MS if you want to export them. But yeah, that's the best way to get the data, or you can just print things out.